Welcome to CBSEasy.
Hey everyone, and welcome. If you're getting ready for your CBSE Class 10 exams, you know just how important this chapter is. Today, we're going to crack the code of electromagnetism. We'll break it all down, piece by piece, so you can absolutely nail these key concepts. Let's jump right in. All right, to kick things off, a question for you. What's the hidden link between a simple copper wire with electricity flowing through it and a powerful magnet? I mean, they seem like totally different things, right? But what if I told you they're basically two sides of the same coin? As you're about to see, the link is, well, electric.
And you know, the craziest part, this whole field of science, this massive connection, it all kicked off completely by accident. It's one of those amazing stories in science that started with just a surprising little observation.
So get this. It's 1820, and Hans Christian Ørsted is in the middle of a lecture. He notices that whenever he switches on an electric circuit, the needle on a compass nearby just twitches. It moves. I mean, it sounds small, right? But that tiny little twitch, it was absolutely revolutionary. It was the first real proof that electricity can actually create magnetism. They weren't these separate forces at all, they were connected.
Okay, so we've established that an electric current makes a magnetic field. But what does that even look like? You can't see it, right? It's a totally invisible force field. So to really get a grip on it, we need to find a way to visualize this invisible force.
And check this out. This is a super cool way to do just that. If you sprinkle tiny iron filings around a bar magnet, they don't just fall in a messy pile. Nope. They actually line up and form this incredible, beautiful pattern. What you're seeing is basically a map of that invisible force field.
We call these patterns magnetic field lines. Think of them as like invisible roads that tell a compass where to go. Now, are these lines really there? No, they're imaginary, but they are a super powerful tool for helping us understand how all this works.
Okay, everyone listen up, because this is pure exam gold. You will absolutely see questions about this stuff. So a few key things you've got to remember. The lines always come out of the North Pole and go into the South Pole on the outside, but inside the magnet, they go from south back to north, making these complete closed loops. And a huge one, they never, ever cross each other. And see how they're all crowded together at the ends, at the poles? That's where the magnetic field is the strongest. Seriously, burn this slide into your brain.
All right, so a current creates a magnetic field. We got that. But which way does it point? Clockwise? Counterclockwise? For your exams, you're definitely going to have to figure this out. And lucky for us, there's a really simple trick for it. So imagine you've got a straight wire, and there's a current flowing right through it. We know the magnetic field is going to form circles around that wire. But which way are those circles going? That's the million-dollar question. And the right-hand thumb rule is going to give us the answer. Okay, I want everyone to actually do this with me right now. No, seriously. Hold up your right hand, pretend you're grabbing that wire, make sure your thumb is pointing in the same direction as the current. Now, just look at the way your fingers are naturally wrapping around. That, right there, that's the direction of the magnetic field lines. See? Super simple. It's a handy little physical trick to solve a physics problem every single time.
Okay, let's level up. We've got our first tool down. Now let's build on that. This is where it gets really interesting. What do you think happens when you take a wire that's already carrying a current and then you stick it inside a different magnetic field? You got it. The two magnetic fields basically push against each other, and the wire actually gets moved. It feels a force. And this isn't just some random classroom experiment. This is literally the principle behind every single electric motor on the planet. From the fan on your desk to the engine in an electric car, this is what makes them go. So we know there's a force, but which way is it going to push the wire? Up? Down, left, right? For this, it's time to use your other hand. Okay, get your left hand out. Stretch out your thumb, your forefinger, and your middle finger so they're all at right angles to each other. Here's how to remember it. Your forefinger is for the field. Your middle finger points with the current, and that leaves your thumb, which points in the direction of the thrust, or the force. Definitely practice this one a few times. It's another one of those questions that you're almost guaranteed to see. Okay, we've covered some heavy physics. Now, let's bring it all back home. Literally, into your home. Because believe it or not, all of this stuff is happening every single time you just flick a light switch. So take a look at the wiring in your house. It usually comes down to three main wires. You've got the red one, which is the live wire. That's the one bringing in all of the juice. Then you have the black neutral wire, and its job is to complete the circuit, to give the electricity a path back. And the voltage difference between those two, here in India, is 220 volts. And then there's the green one. This is the earth wire, and it is super, super important for safety. And let's talk about that safety because it's so important.
That green earth wire, it's literally a lifesaver. If that live wire accidentally touches the metal body of, say, your toaster, the earth wire gives that huge surge of current a safe path to go straight into the ground instead of through you. Next up, the fuse. You can think of it as a purposefully weak link in the chain. It's designed to melt and break the whole circuit if the current suddenly gets way too high from a short circuit or overloading. Either way, the fuse blows and it protects your expensive gadgets and you.
Okay, let's wrap this up with a really cool thought. We've learned that anywhere there's an electric current, there's a magnetic field. No exceptions. Well, guess what? Your own body is full of tiny electric currents. The nerve cells firing in your brain right now as you're processing this, they're electric. So what did that imply? Does that mean our bodies have magnetic fields?
The answer is yes, absolutely they do. Your body is generating its own magnetic fields all the time. Now, they're incredibly weak, but the fields coming from your heart and your brain are actually strong enough for us to measure with sensitive equipment. And this isn't just a fun fact, it's the entire principle behind powerful medical tools like an MRI, magnetic resonance imaging. So the physics we've been talking about, the stuff in your textbook, it's not just about wires and compasses, it's happening inside your own body right this second. Pretty amazing, right?
Thank you for watching with us. See you next time.